Our lesson for today will be looking at chemical equilibrium. This is lesson 101. This is the first lesson video which will be looking at the basics of this chapter. Let us start. The lesson goal for today, we will be looking at many terms that we will be using throughout this lesson series, or let me say this chapter. So it's very important that you understand the terms that we'll be using. It's very important that you watch this lesson video before you can engage with the next lesson videos based on this chapter. Our first term that we'll be looking at is open chemical system. Now when you talk about open chemical system, you're talking about the reactants, or let me say the products that can escape from the reaction vessel, meaning that suppose we have this container, and then this container is actually opened, and then we have reactants inside this container, and then somehow, since it is opened, the contents inside this container can escape in a form of a gas phase or in a form of liquid phase. As long as the contents inside a container can escape, we refer this as open chemical system. It's actually open. And then we have a closed chemical system. It's when we have a container, or let me say a vessel, that it's actually closed and the contents inside this vessel cannot escape. We refer this to a closed chemical system, and we normally say this container it's isolated from the surroundings, so the contents inside cannot be disturbed by the surrounding of this system. It's isolated. So we have types of reactions. We have reversible reactions and irreversible reactions. Now let us start with irreversible reaction. Suppose we have this reactants, we are reacting A and B to form A, B, or C and D. Let us just say A, B. So we know that these are the reactants. We react the two to form A, B. Now this is a irreversible reaction. Now talking about a reversible reaction, it's when we react C and D to form CD. At the same time, we can actually have a decomposition of CD to form CD. So in this case, we actually have two reactions here. The first one, it's C plus D to give us CD. Then the second one is when we have CD to have C plus D. So you can see that on the second one, it's when we take the reverse of this, we actually move this direction. So the reason why we say it's a reversible reaction means that we have forward reaction and reverse reaction, whereby the reactants react to form a product, or a product actually undergoes decomposition to form the reactants. So in this case, our products, our initial products, it's actually the reactants, and then to form our products, which are the initial reactants. So for chemical equilibrium, we will be focusing on a reversible reaction, and you should be familiar with the terms forward reaction, which refers to from left to right, and reverse reaction, which refers to left to actually right to left. And with a reversible reaction, you should know that the products can be converted back to reactants, so we can actually reverse the reaction. Now let us talk about chemical equilibrium. What is the meaning of chemical equilibrium? Chemical equilibrium is dynamic when the rate of the forward reaction equals to the rate of the reverse reaction. What do you mean by saying dynamic? A dynamic chemical equilibrium is established in a closed system where the forward and reverse reactions of the reversible reaction take place at the same time. So in this case, remember that we talked about two types of systems. We talked about the open system and closed system. The dynamic chemical equilibrium occurs in a closed system. So suppose we have this steel container, it is closed. Then inside this steel container we have water. I don't know if this color is visible enough. Let me actually use this color. We have water inside this steel container, and then somehow we heat up this steel container to an extent whereby the water inside this container starts to evaporate. Basically, in order to evaporate, it reaches its boiling point, and then when it evaporates, it changes the phase from liquid to gas. Then you know that the moment it changes the phase, the gas will move this direction. But remember, this is a closed system, so the contents cannot escape the system or the container. Then once this water reaches this lid, it will be trapped. Then as it is trapped to a point whereby we have enough water here, it will convert back to droplets, and then condensation will take place. So in this case, we can see that the formation of steam as it goes up, it will be the forward reaction, and then the formation of water droplets in a form of condensation will be the reverse reaction. So as this reaction occurs simultaneously, there will be a point whereby the speed of the forward reaction will be equal to the speed of the reverse reaction, whereby more steam is created and more droplets are actually formed. So we call this a dynamic chemical equilibrium, whereby the rate of forward reaction is equal to the rate of reverse reaction. So this is one of the simplest examples that we can use, or scenario, to explain what is chemical equilibrium. Another terms that we should be familiar with is homogeneous reactions and heterogeneous reactions. When we talk about homogeneous reactions, we talk about a reaction whereby all the substances that are taking place in the chemical reaction are in the same phase. We say that type of chemical reaction is a homogeneous. It's actually SO3 here. So you can see that the phases of each substance are in the same phase, or let me say all the phases of the substance are in the same phase, which is in gas phase. And then for heterogeneous reaction, we have substances which they are not in the same phase. Like for example, this chemical reaction. This is in aqueous, this is in gas, and then this is in liquid. You can see that the phases are not the same. So this will refer to a heterogeneous reaction. Now these are the terms that we should understand, and then we have reached our lecture goal or lesson goal. That's it for this lesson video. This is Bahula SJ. Thank you very much.